let us now give an overview of the content of this course. So some people might have already heard some of those terms floating around. So in machine learning, there generally exist two different branches. There's supervised learning on the one hand and unsupervised learning on the other hand. Very briefly speaking, supervised learning is really where I have labeled data and I want to make predictions of those labels, and unsupervised learning is about just finding structure in some data without actually having labeled data. So this week we will cover both of them, but we will only cover linear models of supervised learning and a bit of unsupervised learning, and next week we'll be talking about nonlinear models. So today in particular, I just want to give a brief overview about what is machine learning, what it is useful for, and what are kind of the basic ideas behind it. And we try to explain everything in the context of linear regression. This should help because linear regression is something which you hopefully have covered already in other courses, in statistics for example, but maybe from a different point of view. So we now want to kind of revise linear regression, but from the viewpoint of machine learning. So just viewing linear regression as a machine learning model and just kind of understand the basic way of thinking we have in machine learning about train data and test data, but everything in the context of linear regression. And then we will also talk about bias variance trade-off. Now, bias variance trade-off is something very important and is really at the heart of any machine learning model. So if you are able to understand this in a simple context such as linear regression, you will be able to translate it to really any machine learning model as we go along. And at the very end of this of today's session, I want to talk a little bit also about sklearn. sklearn is the package which includes a lot of the machine learning algorithms in Python. So you don't have to code them up yourself, you can just import them using this package. So I will explain you very briefly what it is and how it works. It should give you some guidance when starting with the tutorials there. So as I said, today the focus is on linear regression, which is obviously a model where I want to predict a continuous variable, such as next year's GDP, for example, whereas classification is something where I want to make predictions about a discrete variables, different labels. Could be cancer, no cancer, but it could also be multi-class classification. And we'll be talking about a very simple two-class classification using a linear model, which leads us to logistic regression. But we will also talk about some other models such as discriminant analysis, where you have both linear as well as quadratic versions. And we will talk about the similarities between the different models for classification there. Now on day 3, we move on to regularization. Regularization is very important in machine learning. It helps us to kind of tame models, especially a lot of the nonlinear models we will be talking about next week. They have many parameters and it's very easy to be overfitting, where we're just fitting to the noise of the data and we are not really covering the structure. And there, regularization comes to our rescue and it will help us to control the complexity of the model in a very systematic manner. And one of the techniques we'll be talking about is lasso, which is a very nice way of regularization, which leaves us with some form of interpretability as well, telling us which parameters are useful and which not. And now on the last day, day 4, we'll be talking about unsupervised learning, in particular some simple approaches such as dimensional reduction using principal component analysis or PCA, as well as clustering. So this will be all the unsupervised learning we will be doing in this course, because next week we'll be moving on to talk about supervised learning again, but more complex nonlinear models. So just to give you a brief overview of next week. So as I said, next week is all about nonlinear models and modern machine learning, and in particular on day 5 we will talk about tree-based models such as boosting and random forest. They're very important. They're really at the heart of your data science toolkit. They're very versatile and you can apply them in really a variety of applications. and also they are very user friendly. It's much easier to employ them than it is to employ deep neural networks. It's a lot less domain knowledge needed to understand and use those models than there is for some of the deep learning models around there. So this will be day 5. Day 6 we talk about support vector machine, another very much used model for classification, which can also scale very well. So some of the techniques we talked about, not everything really scales to really big data. So support vector machines does, and it's a really nice techniques of applying classification in a nonlinear setting there. So, and for the last 2 days, day 7 and 8, we'll be moving to neural networks and deep learning. Obviously, neural networks and deep learning is a very big field, and you can give an entire course about this, and so we will just be restricting us to 2 days, but I hope this will help you to get a basic understanding and really connect to some of the more recent state-of-the-art literature there, especially if you're planning to do anything related to kind of image recognition or natural language processing. You really need to know a little bit about neural networks. So kind of day 7 we will just be talking about very basic neural networks, how they are trained using backpropagation, and kind of what are the modern ways of actually implementing those in Python using, for example, TensorFlow. Now, the last day we talk a little bit about more modern techniques of deep learning, such as convolutional neural networks, recurrent neural networks, as well as modern techniques of optimizing or training those neural network architectures, such as the Adam optimizer. And this will obviously a little bit more of a briefer overview, but it should hopefully give you a good starting point for further studies, depending on which direction you plan to go. So let us now move on and talk a little bit about machine learning in general.